Okay, let's talk about pricing bonds with embedded options in them. We have the given information that's here in blue. And the first thing I would want you to do is find the spot rates. We won't go over the details of that because you've done that in something else, so you should be able to find those. We're also told that the volatility of interest rates is 10%, so that sigma, that volatility, is given. So the first thing to do is price an option-free bond that has a coupon rate of 10%. And that's the way we do that is over here. We say 10 divided by 1.06061 plus 10 divided by 1.07383 squared plus 110 divided by 1.08003 cubed. So taking these spot rates and putting them here in the denominator, I come up with the price, which is that 105 number, and you can see each one of the components right there. Okay, so now that we have that done, we can use this number when we're finished if we want to check and make sure our work has been done correctly. So what we want to do is build out an interest rate tree. So here is our final product. We know this first number right here because that's the root rate of our tree, and we know it from right here. We've already found that. What we need to do next is find this interest rate. Knowing that interest rate, it will then tell us this interest rate. The next thing we need to do is find this rate. Knowing that rate tells us this one and this one. And so now those rates in red are going to be our interest rate tree, and I can price virtually any bond using that interest rate tree. Here's the process I go through to find the tree. I start with the 2-year, which has a 4% coupon. Knowing that, I know the following payments. I know the coupon payment. Well, let me do this first. Say this is time 0 right here. Time 0. This is time 1, year 1. And then here at the end, this is time 2. It's a 4% coupon. So I know that I'm going to get paid a $4 coupon. It does not matter. Now I'm going to use the term rates going up and rates going down. And what I mean is going up the tree or down the tree. And I notice that rates went up in both cases, but we can either go up the tree or down the tree. So that's what I mean by down or up. So if it's a 4% coupon for $100 par, it doesn't matter if we go up or down, I still get a $4 payment. And if I hang on to the bond and don't sell it, it doesn't matter if rates go up or down or what they do. I'm going to get 104. So rates could go, or we could go up the tree and then up again. We could go up the tree and then back down. We could go down the tree and then back up. We could go down and down again. It doesn't matter which way we go. If we hold the bond to maturity, we're going to get the 100 plus the 4. Okay, so where does this price come from? Where does this 94.935 come from? That 94.935 is equal to, we have a 50% chance of going up. If we go up, we get 104, and discount that back at this interest rate, the 1.09548, plus there's a 50% chance of going down, and we get the exact same thing, 104 when we divide by the same interest rate. And we would do the same thing to get this number. Now let's look at the 94. Where's that 94 come from? The 94 is, there's a 50% chance that I go up and get the 94.935 plus 4. That's discounted back at the current rate. And there's a 50% chance of going down, which is going to be the 96.459 plus 4 divided by that interest rate. So that's where I get the 94 from. Okay, here's what I would like you to be able to do, but you can't do in class with the tools that you have. I need to choose this interest rate. If I know that interest rate, I can find this one. And here's the relationship. 0.07818 e to the 2 sigma, and sigma is 0.1, is equal to the 0.09548. So choosing this rate tells me this rate. Alright, knowing this interest rate tells me this price. Knowing this interest rate gives me this price. Knowing those two prices tells me that price. But I already know what this price should be because I can look in the market. It should be 94. So I need to choose this interest rate so it changes that one, so it changes this price, so it changes this price, so this comes back to be 94. That's what you do in Excel. So what I will do for a test is I will give you multiple interest rate trees and you tell me which one is correct. So now that we have this 7.818, we know that that stays right there. So here's what we know. We know this rate, right, because it is the spot rate. We know this rate and this rate because we found them on this interest rate tree up here. Now I need to find this interest rate right there. Well, in order to find that, I need to choose some rate randomly, which, given the 7.5, I know that this will be 9.2, this will be 11.2. This interest rate determines this price, this interest rate determines this price, this interest rate that price. So where does this price come from? Where is that 96.27? 96.27 is equal to the 97.041 plus 6 over 1.07818, and that's times the 50% chance plus, so if you go up, if you go down, 98.551 plus 6 over 1.07818, and there's a 50% chance. Alright, so where does the 6 come from? This is a 6% coupon, which means it's going to pay me 6 regardless of going up or down the tree. It's going to pay me 6 each time, and there at the end I have the 106. So, you know, if that math is still a little shaky for you, see if you can follow the Excel spreadsheet and you'll see each calculation individually. But now I know that this is the interest rate tree because this comes back to 95, and not exact. Solver didn't do it exactly, but close enough for us. It comes back to 95. So now I have the rate tree. Given this interest rate tree, I can price virtually any bond. So rather than pricing the bond I already know, I want to price the new bond with a 10% coupon. Okay, so let me get that off of Excel and put it up here. Okay, so first let's take a look at this bond right here. I'm saying that this bond is going to be callable at 104% of par in 1 year and 104% of par at year 2. So this is a 3-year 10% coupon bond. So it's going to pay the 10% coupon, right, each year, regardless if we go up the tree or down the tree, and you hold it the entire 3 years of maturity, and it's going to be 100 plus 10. Now if you look back in the video, the price that we had before was almost exactly the same as this price. The only difference is that I have a little rounding error in these interest rates. Okay, so what I would do on a test would be something like this. I would have you have determined that this is the correct tree from before, and now I could go through here and I could say, I'll mark out this, I'm going to mark this out, you know, I could mark this out, any of those, and tell you to fill in the blank. So let's just fill in the blank for this one. If you didn't know, well, sorry, let's do for this one, fill in that blank. Well, you know that should be equal to 100.703. Hang on. Gotta do this right. So this should be equal to 100.703 plus 10 divided by 1.7818, leaving off an 8, and there's a 50% chance, plus there's a 50% chance of getting 102,270 plus 10 divided by 1.07818. So go down and get this, there's a 50% chance. Go up and get this, there's a 50% chance. I work backwards and I can find that the answer is 103.403. So I can do that, and that's pricing a bond that's callable at these really high rates, and there's no effect when it's callable at these high rates. Here's the next thing. Yeah, I intentionally got those rates the call values really high. What if it's callable at 102 in a year and 101 at year 2? Well, this is essentially, because these are so high, we can think about this over here as the non-callable, and this one the callable bond. And like I said, because these call premiums are so large, they're never exercised, so this is the exact same price as a non-callable bond. If it's callable at 101, when you do the math right here, you don't get 101. When you do the math right there, you actually got 102.270. But if rates ever went to this point, it would be called, the issuer would call it back in, and they would pay you 101. So the actual price at this point is 101. And now to get this value, this 102 value, you use 101 in, so it would be, the price would be 50% chance of getting 101 plus 10 divided by 1.07818 plus a 50% chance of getting the 100.703 plus 10 over 1.07818. That number, I don't have it written down, is greater than 102. So whatever this number comes out to be, I know it's more than 102. I'll put 103 and a little question mark. But it's callable at 102, so you don't actually, this price never exists. The issuer calls it in at 102. So now what we have is the new price. This is the price of the callable bond, right? So all that's changed between this is the callable and this is the non-callable. The only differences are it's called at this point and it's called at this point. Look at these others. This is below 101, it wouldn't be called there. Below 101 would not be called. Below 102 would not be called. So now we can look at the price differences. 105.4176 minus 104.7561. This is the price of the embedded call option. So that's basically everything that you have to do for the embedded calls. Like I said before, it's too complicated for you to build it from scratch. So I might cross out an interest rate, you fill in the blank for the interest rate. I might cross out a price, you fill in the blank for the price. And if it's callable, you know to compare that price to the call premium. So you're comparing this price right here, whatever you calculated to the call premium there, and you're taking the smaller. If it was puttable, it would be the opposite. You would take the larger price. And I think that's basically it.